is my stats project, and my name is Eric Garrison Hurst, and I gotta present this. I put all the numbers on CodeCalc, and when I started out with the 10 flips, most of the time went for this first one went for heads a lot, not for tails. Not for tails mostly. This next one right here, I had it flipped a lot too, and it went mostly again to heads, but was 50% on tails and heads really. This one was mostly heads. Again. The outcomes of these were a little more 50%. And as you can see, most of these graphs are reaching the 50% mark, except for this one right here. This one's still a little more biased in its approach. But these two are definitely hitting 50%. And the outcome is largely the same, moving towards 50% mark, like I said. That 10,000 flips is where it comes mostly to half and half. As you can see, the line that predicted it was going to be half and half has become more prominent and seen upon, especially in this one right here. There's still a little more. There's still some outliers, like this part right here. That's a spike of either tails and a spike of heads, but largely 50%. And the 1,000 flips is it starts out a little biased, but totally became a 50-50 thing. Like all coin flips should be. 10,000 flips is 50-50. So for question 1, the probability was that was in favor at first for heads or tails, but mostly for heads. But then as we kept flipping, it ended up being a 50% split. And at the same size, as it got larger, most of the graphs started to look the same. As the sample size got larger, they started to look the same. And the law of large numbers states that if you keep performing the same task more times, you do it higher. You have a higher chance to hit the equilibrium or predicted probability. And that's what we did. We hit the predicted 50% as long as we kept growing. As long as the sample size kept growing. As long as we keep flipping the coin, we're gonna get 50%. The second part, when I rolled the dice at first, the rolls are all over the place, kind of like these graphs, but there was some semblance of order, like in this one. You can see some semblance of higher in the middle. As I kept rolling it, you can see a form of some kind of bell shape, still a little crooked, but you're gonna get more even rolls as you keep rolling. And when you hit the higher numbers, you get almost a perfect bell shape for every one, because the amount of rolls you're gonna keep hitting the same numbers, like 1, 2, 3, 4, 5, and 6, and you will keep hitting the same numbers every time because of the amount of rolls. And the last one is perfectly bell shaped, so that means you keep hitting the same amount of numbers, the same amount of rolls. So yeah. In conclusion, the probability distribution became more and more bell shaped because you're hitting the same numbers over and over again, and it's going to be even. I expected from the dice roll on the coin flip that the law of large numbers was right, and saying that the larger you get, the more it's going to be a predictable outcome. And in casinos, one person might win, yes, but in the big picture, the predictable outcome is that more people will lose and win and waste their money, and that's how they make money. More people lose than win, and they know that because of the law of large numbers, saying that if you do a task more and more times, you'll have more and more chance to lose than win. And that is my report.